To understand why firms pay more than the welfare benefits and why workers work harder when wages are higher, we use the so-called labor discipline model. In its simplest form, the model features two players, an owner and a worker. The owner is the one hiring or demanding labor, and the worker is the one who supplies her labor. So, how do we model this game? The game is sequential, similar to the ultimatum game. We know that when a game is sequential, one of the players makes a move first. In the ultimatum game, the proposer proposes a split. Here, it will be a wage offer. And because the markets and policies can change, the game is being repeated. This means it's being played often, every period. Thus, we get a model which is closer to reality. If you think about it, this is similar to what happens in reality. Often, workers go and negotiate a promotion and a raise after becoming indispensable on the job. But before that, the employer has to offer them the job in the first place. So, it is the employer who offers the pay. We call it a wage offer. And then it's the worker, in this case Maria, who chooses how hard she wants to work based on the offer. Now, the level of effort Maria chooses has been normalized to an interval between 0 and 1. 0 means the start of the working day, and 1 is the end of the working day. So let's say Maria chooses a level of effort equal to 0.5. This means she works at her potential half of the day, and the rest of the time she doesn't work for the firm at all. For example, in the rest of the day she checks her Instagram profile or browses through the comments on her TikTok videos, for example. As in any game, there are not only rules and players and strategies, but also payoffs. The payoffs is what both agents get from the interaction. In this case, the firm gets the profit from hiring Maria, and Maria gets the employment rent, the difference between what she gets and what her outside option is. Assuming, of course, that she doesn't have direct costs of being employed. In this case, she has only opportunity costs. So let's place this game on a graph. The offer that the firm has for Maria is on the horizontal axis. The level of effort, on the other hand, she chooses to apply is on the vertical axis, as she can't work longer than a full day at her maximum capacity. The maximum level of effort for her is equal to 1. Now, all the action between Maria and the firm happens in the wage-effort space. Now, let's discuss what happens in this wage-effort space. Let's have a welfare benefit of $6 per hour if Maria is unemployed. We believe there's no point for Maria to show up for work at all if all she will get is the welfare benefit, is there? So that's why at an offer equal to the welfare benefit, equal to 6, Maria will just apply an effort of 0. She wouldn't work. She wouldn't care. We call the level of wages at which workers are really ready to offer any positive effort with the concept of reservation wage. In this case, $6 per hour is the reservation wage for Maria. Okay, we've got what Maria will do if the firm offers her a wage of 6. But how about a higher wage? Notice how a small increase in the wage above 6 will induce large effort increase for Maria. This is so because at low levels of effort, she can work harder without any meaningful struggle. But as she applies more and more effort, the firm needs to compensate her by increasing higher wage offers to make her work harder. This is because it becomes increasingly hard for Maria to exert higher effort from her as she approaches her maximum working capacity. So we can safely say that the best response curve of Maria reflects the fact that she needs to be compensated by increasingly more money to motivate her to work harder as she approaches her maximum working capacity. In a way, Maria's best response curve tells you how she transforms $1 of wages into effort. Note that Maria's best response will depend on the state of the economy. If the unemployment duration is 44 weeks, then what we're seeing here will be her optimal transformation of wages into effort. However, if the unemployment duration is longer or shorter, this will inevitably affect how she feels about exercising effort. We'll discuss the changes in these transformations of wages into effort during our live classes and seminars. For now, it's good to remember and understand that at low wages, $1 more per hour means a lot to Maria, so she exerts a lot of extra effort. However, as the wage increases, she's got a lot of dollars per hour, right? So to make her work even harder, the firm needs to compensate her very generously. Plus, let's face it, it becomes increasingly harder to work at your full capacity. So, at high levels of effort, it becomes increasingly expensive for the firm to exert even more from their workers. Note how the slope of these two lines passing through points J and K are different. This is exactly what we're talking about here. Now, we've seen this before, haven't we? Certain resources get transformed into output at a certain rate. Before, it was the production function transforming hours of work of free time into, or free time, hours of work or free time into production, into output. Now it's $1 of compensation producing some extra effort from the worker. In both cases, the curves here show what is technically possible to do. That's why we call them feasible sets. Remember, the slope of these feasibility constraint, feasible sets, always tells you how you transform a certain resource into a certain output. That's why we call the slope the marginal rate of transformation, MRT, sometimes the marginal rate of technical transformation, to emphasize the fact that this is a technical parameter we're talking about here. In this case, the transformation of wages into effort. But as in any individual level optimization model, we don't only need the feasibility constraint. We also need information on how costly it is to be on that constraint, so that we can find an optimal point for the firm. We'll see how costly it is to exert this effort in the next video. Thanks for watching.